Hey guys, and welcome to the second video, the second part of the introductory GIS applications class CE375. Before I start the second part, if you remember in our first video we talked in this slide here, one of the definitions of GIS, and I've asked you to pick up one of these, and I haven't picked up actually my favorite. And when I talk about favorite, let me put here my pointer so I can start pointing. When I talk about my favorite, I have this one here. This is the most comprehensive definition of GIS. So they're a group of tools, not only tools, some people, for collecting, managing, storing, analysis, display, and distribution of information that has some spatial part of it, when you call here spatial data and information. So this was just input before we continue working, guys. So we did this last, and we stopped at this slide here. And again, we're gonna have a specific lecture about the different data structures that we use. We're gonna actually specify each one of these data structures, and we're gonna have also labs on how to use ArcGIS to do these structures. So when we talk about structures, we want now to map and get some information about locations of things. Number one, we have something called discrete data structure, and this map here shows the meaning of discrete. Discrete means that you have features like these points over here. These are called features, like for example this feature here, and they're discrete, meaning that they're not continuous throughout the map. You draw them or you locate them in a specific location. Every one of these points has its own coordinates, and we define this also in our lab class as what we call here vector data structure or vector data model. And we had three types of vectors. Number one, point has no dimensions, just a location, some coordinate showing exactly where is this point, and we can connect some data, some attributes to that specific point. So that's the one point, and it has some kind of coordinate. Number two, when we have points, and this map here, the US map you can see here, is a point map, or a point vector, or a point layer. Actually, you can add more layers of other stuff. For example, if you look in the same map, you might find some of the interstate system, so that's a line. And here comes the second part here, when we have a line, when we have two or more points, when it changes direction, and we pass some what we call here line segments between these points, and every point has its own x and y. So this is called a line vector, or a line. You can see it is discrete. Line segments create a line. So we have here point, we have here line. If these lines start and end on the same point, which creates some kind of a shape, we call this area or polygon. So each one of these data structures is an item, a feature by itself. We can connect to this line some information. For example, this line is borders of this state. The polygon is the state itself, and points are different points of this polygon. So that's the first type of data structure. The second one, which we call here continuous. Why is this discrete? Because it just covers this area. If you look here, we do not have any other information, just talking about this polygon. For example, in this map, we're only talking about these red dots here. We're not talking about anything else. When we want to find something else, or we want to map something that is continuous throughout the map, so it covers every single part of your map. For example, if you want to cover all elevations, temperature, weather, rainfall, snowfall, depth of ocean, we use something called continuous. Another name for it, we're going to be dealing with it in detail in this class, what we call here raster models. We as engineers, we don't do much of these raster. We're more interested in discrete, but still raster is a very important part of our work. How do we do it as surveyors? We have an area, and they start creating points with their total station and their equipment, and they start creating these kind of a grid, exactly like the grid of your TV or screen, and each point has a number, and it creates this kind of a map, and each number is then divided into a pixel, and this pixel takes the number, takes a color, and you can create something like you can see here in this map of West Virginia. Different landside hazard data show where you have more hazards, and it's continuous throughout the map of West Virginia. How do we create it? Every point has a specific, and we created this kind of pixels, and the pixels create this shape of raster model. A third type, and it's something that we'll be doing a lot in this class, is that sometimes we want to summarize some kind of attribute data value and the location all in one. So here, properties and attributes or these features. For example, this is a map that shows different counties, all the counties in the United States, and we have a data connected to it, school ratings. So we average the school ratings throughout the whole county. For example, this county here has a really good school rating. How do you define it? We have, let's say, 25 schools, each one has a rating. We average that and we apply it to the whole county, and this is the meaning of summarizing by data value. This is the third type of modeling and showing our data in our map. So to summarize here, spatial data is two things. You notice that: where, the location, coordinates, and what, which gives you the properties and attributes of these features. We also call it aspatial data. So here, this is where, whatever these cities about, probably these are the cities that have a number of population in the US, so that's where. And what is the population, and that's what we call here attributes. And in our second lab, we're going to be looking a lot about attribute tables and how to organize this and work with that. So another good example here, and that's probably something that you might have seen when you bought a house or put some infrastructure in your house, is that you can see here the yellow rectangles and the blue rectangles show the house, and every of these yellow rectangles and also any of these lots, and lots here are the one bounded by the roads, has some kind, for this example 4325, we have something called an attribute table, and this is the information database. So the address, which subdivision, block, who's the owner, the value. If you go to all these websites that gives values of houses, it puts it in maps, and you can also put it in a table. So this is what we call here attribute table, and we link now this spatial data in a map, the location exactly, to whatever information you can add to it, and this is what we'll be doing in a GIS. There are tons of examples that connect what to when, where. Where is, for example, here in this map here, and we have different counties of West Virginia, that's the answer of where. And then we have some kind of census tracts. Census tracts are any information that are collected by the guy who came and took some census information from you, and we can do lots of things: income, population, density, you name it, we can do it. We talked about this map about landslide, so it's data, so where, and we connect here some kind of a you can see a risk and problems when we have here a landslide throughout our state. Well, West Virginia is an oil and gas and energy state, so also we want to figure out where are the oil and gas wells and coal, and people who are interested in energy might find this map very important to know exactly where are the hotspots for example, natural gas. So another thing we'll be doing in this class is what we call here spatial relationships. and it's something that we care about in maps, is where who's affected by what. I was watching a map in the news early today about counties that are the most affected by the COVID-19 pandemic, and where is it affected, how does counties affect each other. This is exactly what we'll be doing here. You can notice in these maps here that feature attributes often depend on the spatial arrangement of other features. For example, if you have a pollution area and you want to know how much this pollution is spread throughout the area, so we can create some kind of a heat map and some kind of a contour map that shows, for example, if we have a problem here in this area and we want to know how much does it affect others. We use this when we talk, for example, about tons of uses, schools, school areas, school buses. This is just one example. So GIS aids analysis and display what we call here spatial analysis or spatial relationships. There are different spatial relationships: inclusion, intersection, areas that are next to each other. So we have different ways to put these spatial relationships to each other. So again, we tend to look at where and what, the location, important features. We tend to look at the properties and attributes of these features, the answer of what. So you as the user will decide what features are important. And we use this feature thing, location, by use of coordinates. We're going to talk about coordinate systems throughout this class and figure out exactly where is the location of every specific point on the earth and how do we map it in different tons of ways, which we call here coordinate systems. So coordinates, well, you already know that as engineers, they are simply numbers that describe the position of the feature object on earth. So GIS, guys, is the only way to solve any database and related to some kind of a spatial database by adding this feature to these features here, by adding the X and Y, the location of exact features, and have it connected to others. So GIS does spatial analysis and displaying spatial data. GIS is very instrumental in addressing societal problems, and also it's very important for us as engineers to add some location to all our data. A very good example, if you remember, guys, a few years ago when we had our pollution problem in the water, especially in the Charleston area, and we had this spill, and people were stuck to this map trying to figure out if they are affected by this spill or not. And a map gives you an idea on how spread this spill and who is affected by this spill. This is kind of spatial analysis that we do in a lot, and you can see how important now GIS is to exactly know who was affected by that spill. When we talk about the storm, when we talk about some disasters, who is affected, where is the storm located, what is the if a storm is going different ways, what model tells me about this storm. GIS and mapping is one important input in that. Really more local example, which I love, when you have a pizza delivery. Well, if you look at any pizza shop, you're gonna find a big map for delivery guys to know exactly this is it, this is my store and I live here and I'm calling for pizza, and he says, you know what, you're out of my area, I cannot go there. Why? Because he has his own specific area. So here, this is what we call here GIS for, so even a pizza shop needs some kind of a GIS system to help its delivery people to get your pizza to your place. So that's another use. School buses and school zones. When school buses has its routes and you want to know if you are on that route or not, well, for you to know exactly, you need some kind of a GIS that tells you where are the routes of the school buses. Final thing talking about this lecture here is something that it's like a philosophical part of GIS. Why did we develop GIS, and happen? Like, why was it so important? Well, we have something called a push and a pull. When we have a development, for example, a development of any new technology, and we ask how did they come up with this technology, there is a push for it, meaning that their society pushed for to develop this thing. So, for example, we invented the wheel. Remember this phrase? Why did people invent the wheel? There is a push for it because people wanted to move from one place to another, and that's the meaning of a push. When you have some kind of motivation to develop something. So the push here is what we call here environmental and societal push. And there's a pull, something that helped that. And here comes the word technology. So you wanted to invent the wheel? Well, we had some tools, and these tools helped you invent the wheel. Same in GIS. There was push from the society to develop. For example, you wanted to, for a war or for discovery, we wanted to develop some kind of mapping systems and ways to help. Well, we have some technologies, and technologies created this pull. So let's talk about the push first. So humans, unfortunately, we are one of the worst creatures in this earth. We created very negative impacts on our environment, and we wanted, and since the land is so limited and the resources are very, very limited, we want to best manage and operate these scarce resources that already used by humans. So we want to figure out, okay, where are the problems? We wanted to know exactly what's going on, where is it happening, weather problems as well. And for example here, global warming, and global warming is causing our ice glaciers to melt. So we had a problem here, and I want to know exactly where is happening the most problem and how can we start researching that. So we want to map natural human damages, pollution and flooding, and repeated observations allow us to overlay observation, measurements, impacts, and do some recovery plans. So when we put here, for example, we have a factor, let's say pollution, and let me get here to this. So here factor 1, some factors of pollution, and we want to put them all together to figure out what went wrong. So here we want to know what's going on. Let's say imagine we have a spill, or we have global warming, where is it happening, we have a storm. So something we want to map. So here environmental and societal problems cause us to know, want to know exactly what happened. So we want to overlay this in each other. And here came the use of GIS, not only answering the question of where, but what are the effects of different things that we did. And this is a beauty about GIS, that we can put different factors into one composite map. And here comes the push for developing and improving the GIS. So GIS used to document changes, mitigate damage, and manage natural resources. For example, this is a new nice picture of flooding. We cannot have this picture without some kind of a GIS, knowing exact the flooding. So here we put the different information about the river or the lake and the effect of the damage that happens. So GIS helps identify source, location, extent of adverse impacts. We put some maps over each other, and we can create another map that will tell us how damaged it is. Okay. So here, GIS helps us create practical plans for monitoring, managing, and mitigating damage. So it's a very nice tool for us to exactly know. Just look at the movie when they have a fugitive, or when there is a problem somewhere, and they look at the map and they try to figure out what went wrong. So for emergency service, for flood protection, for disasters, and infrastructure development. And for us as businesses, we want to increase the efficiency in delivery of goods and service. Remember the pizza example, the UPS, FedEx, Walmart locations, where to put our new store. We need to create some kind of analysis spatially with the use of GIS that will help us find new locations and find new customers as businessmen. So these are the 5 different why GIS that create the push. We want to identify problems, we want to map the damages happened, we want to document changes, we want to identify source, location, extent of these impacts, we want to help some plans to help and mitigate this, and we want to increase the efficiency for us. And then comes the pull, and here's the beauty now. Now, in the last, let's say, 50 years, with the invention of computers, satellites, GPS, and other very useful equipment, and now drones. Drones is another additional part here. And GIS, by the way, we have a different name for it. We're going to talk about this in this class. It's actually called Global Navigation Satellite Systems, which is the more comprehensive definition for that. So here we have some technologies: GNSS, computing systems. Computers is one important thing, and the powerful computers that get powerful every single day, and smartphones and different technologies. These all created the pull that helped this kind of developing of GIS. This is another picture, guys, of showing you what we talked about remote sensing in our first video. This is called photogrammetry, taking pictures from some kind of an airplane and putting these pictures together, aerial photos, to know a lot about surveying of this land. Or we use also satellites. This is satellites for GNSS, but we also have satellites that does remote sensing. So we have here GNSS, computing and storage technologies, some cameras, and we all do some kind of conversion of all this information to some spatial information. Photogrammetry is something that happened in the 70s and 80s, and you can't imagine how much it helped a lot. And all these aerial photos you find on Google Earth comes from both satellites and photogrammetry, or these aeroplanes that create aerial photos. So the use of photogrammetry, surveying and mapping to measure distance between objects, and you can't imagine, these pictures are used to do surveying. Can you imagine that? And later on it will be turned into what you will be doing a lot in this class, using it in a GIS mapping system. This is a really good example. It's not about Earth, it's about technology used by computers. If you wanted to create a 3D model, and we use this a lot in movies, especially computer animation movies, we want to create a 3D model of this statue. So they start taking pictures around the statue, and the computer will help generate this kind of a 3D model. We do exactly the same in land. So you can see here the technology of programming and computers helps us a lot in doing that. And then comes the science of GCSI, which is the theoretical foundation background. This is what we do in our classes, in our lectures. What is the science behind this mapping? So we have two parts. We have the labs where we do our maps and we do our analysis, but there's a science behind it, and we as engineers, we actually share most of this science. So technical aspects: how to conceptualize geography, collect, repeat, represent, store, visualize, analyze, use and present geographic concepts in a way that is systematic, and we use the technology here to help us with that. There are different disciplines under the word GIS and surveying. So you can become a cartography. You just create maps. You're an artist more than an engineer. You can work in photogrammetry and remote sensing, especially if you love satellites and airplanes, and now drones. You do some spatial statistics. We talked about this, that we have data, but it now has space. So there's a new science called spatial modeling, statistical modeling of spatial patterns and process, and how, for example, this flooding map that I showed you, how it will be affected in the future. So we create some statistics of models. When you hear the weather guy, when he talks about models about the storm, which way it's gonna go, it uses some kind of this spatial statistics models that try to figure out in the future where will the storm go. And in GIS we integrate all these tools into one specific system, and you as a GIS person, you can go into one of all these disciplines. So with the GIS, it's possible for you to map, model, query and analyze large quantities of data, all held together within one single database, and that's the beauty about it. That's why it's a heavy program. It's a big program. We do data input, storage, we transform, analysis, we do some model, and then we can create reports that will help the decision maker to do some decisions about the environment or about political reasons, or sometimes even war. And then final thing we're going to talk about in this class is that GIS has 5 components, like you can see. we have number one. Let's start here with the computers. So number one, we have hardware, and in simplest form, hardware is your pencil and paper. So that's the first thing. Number two, software. So we have this kind of database system spatially that creates and analyzes the data and creates maps. And we have the data. So we collect tons of data, surveying, maps, pictures, aerial photos, satellite photos. And we have some kind of procedures that will help us analyze this data in a way that we'll understand it and we'll be able to map it. All this is done by you guys, by GIS. Out of these five, which is the most expensive and valuable resource or component? That guy. To train a GIS personnel and have them, it's one of the most important parts, and that's why all the DOTs always connect with us, and they always want to hire you guys and have you as internships in their departments, because you are trained engineers. So this is the most valuable asset in the GIS components. Okay guys, another just picture that shows the five, and I will just leave you read it. So here with the definition of GIS, we can see here the hardware, software, data, some people and some methods, some guidelines and specs, standards and procedures to analyze the data. And it's the way people here are trained to do a GIS. So the people who are hired and they're trained, they figure out what are the methods, they train about the methods, they have an idea how to use the hardware and how to use the software to start working and analyzing the data. So you can notice here that the people or the users are the core of this business, not the computer, not the software, it's you guys. So you have always to make sure that you are the main asset and the main core of this business. Talking about the business, you notice that GIS is used every single discipline. So it's a multi-billion dollar industry, and there are different things in GIS that we want to think about. And remember guys, our project in this class is talking about innovation and entrepreneurship, and we're going to create some kind of ideas that will be used in our GIS class. So it can be in one of these, maybe more, you tell me guys. Number one, software development. Can we create an application or a software to innovate in GIS? Well, think about it. Data, and data is done in a special way for ArcGIS and other software to read and analyze. Is there another way to process and get and distribute data? And then comes number three, and this is probably the one that you can invent the most and work most on. What's the value added to industries? For example, let's talk here about the pizza people. They want to deliver their pizza the fastest way possible before the pizza gets cold. So is there a value that we can add as GIS with an application that will help the pizza people to do that and deliver the pizza with no traffic and the fastest way possible? So think about it guys. Are there any other ideas that we need to talk about that can bring money, bring more to this multi-billion industry of GIS? Let's talk about this more in our class, because I want to make some kind of brainstorming with you about that. So we might assume that they're given tremendous amount of public and private geospatial data that are collected throughout these. You notice if you go to GIS research, you're going to find that people are collecting data for years, and we have data in both the DOTs and the governments, all kinds of governments, all kinds of libraries have tons of data. You might tell yourself, well, they collected everything, we're done here. Well, no. Earth has been mapped already? Well, it has been mapped, but no. Geographic phenomena is continuously changing. People move from one place to another. Cities change. If you just go to one city you lived in a few years ago, go there, you're gonna be totally different. So people have their huge effect on land. Land use changes. Pollution. pollution changes from one day to another. Global warming is different. So weather is different every single hour. Transportation networks change from one day to another. Highways, land use, even our North Pole glaciers that are changing in a very, very fast rate and causing issues to the whole world. So the land is changing. Even our crust, the Earth crust, is changing every single year. So we always need data. So it's not a stopped or done deal. No, there is still work under progress. So many different GIS related businesses that continuously collect and analyze spatial data that could be incorporated into a GIS. So here we want to just try to digest this sentence here and try to figure out how can we have our own business that deals with GIS. And a good example here, you might hear the word Waze, which is an application that even being used by local stations to figure out the problems with traffic. So it's an application, so simple. You download the software and you report if there's a policeman or report if there's an accident. And more reports will create this kind of Wazers. And it's an idea, and the application developers made tons of money out of it. So that's a good example. Have a look at, do some research about this Waze application. You can imagine it's made use of maps and GIS. You can imagine how it made a big thing. Another example, Uber. Uber uses maps to get your ride. Uber Eats, DoorDash, and other ways to deliver your food. They all depend on GIS. Now let's talk about jobs. Probably most of you have already secured a job in your degree. Some of you are still looking for a job. If you're thinking about jobs in related GIS, just check these websites, and the PDF of this presentation is available on your web page. So have a look at these websites. Maybe you find a good job in GIS. When we want to invest in GIS, let's say we want to create a GIS, so it's not easy, especially training people, so it's some expensive, but it's a very invaluable tool once it's created, because so when we want to create a development of business of GIS, it might cost some money at the beginning, especially the programming and training people, but once it's done, you can't imagine how it's very, very invaluable tool. It can help you make some informed spatial decisions and mapping. Imagine that you just put a store anywhere, you don't care what it is, and it wasn't studied well, and then you lost money. So GIS will help you knowing people around who's going to use your product. This will help you know a little bit about where to put your product or where to put your business. So it's very important tool, and you're not the decision maker, but instead we're making use of data to make decisions. And here comes the word SDSS. SDSS is short for Spatial Decision Support System, which uses a GIS. It's a computer-based spatial information. So it's GIS that was developed or worked on that to create this kind of the SDSS. It supports businesses and organization decision-making activities. So it's like a support system. For example, here, when you are using Uber always depends on a map. So the map here is a decision support system that has a transportation system that helps the driver know exactly where to go once you put the address of your destination. Another good example, and I want you all to have a look at this, is our state, West Virginia DOT. They have their own mapping system, and it's still a work in progress, but they're doing a great job in having all information of all uses in West Virginia, starting from transportation to resources to natural lakes, rivers, and everything else. So have a look at this website as well, and I think by this we're done. I urge everyone to start reading an introduction chapter in your textbook or any other textbook of GIS. It will help you a little bit more understanding more about the word GIS and how to create a geographic information systems. So again, guys, thank you so much, and see you in the next video. and we're going to talk more specifics about some of the items in GIS. Have a great day, and thank you so much.